This time with the same old, same old. Here's mine. Oh shit, I didn't even see that. Oh yeah, yeah. I think that's what we ended up doing in the end. Anyhow, so we're back, and in this video, or live stream, depends on who you are and when you're watching it, we are going to apparently sit here looking at whether or not YouTube is working. It looks like it is, but it may not be. I don't know. Yeah, it is. Okay, so depending on who you are, where you're at, and when you're watching, it's either a live stream or a video. Editing, what's that? I don't know. Sure. I just made level 1 on my own Discord. Anyhow, in this one, we're going to take another look and a more look at KeygenMe #1. Now, I had left a comment, view comments. Shit. File, recent files. Oh, challenge. View comment. Nope, that's not it. Recent files. Hey, Johnny Cash, welcome back. Where did I put it? I think it's in downloads, actually. File open. Download. Nope. And let's go. Hey, Alex is back too. Look at that. Everybody's coming on back. Where did I put? Okay, there's a one there. Is it this one? It should be this one. If it's not reading that, well, I'll just go to it. I should be able to remember, I suppose. No, I specifically remember I downloaded from the forum and I put it somewhere. Was I working on it? Ah, screw it. We'll figure it out. So let's get back to where we were. I guess I could reference the video. Search for current module. This is not the right one. Stop. Let's just grab it real quick. Forum. Academy. Let's go. KeygenMe. I swear I did this last time. Show on folder. That's where that download. Now, let's just. Did I put it here? Well, I would. Users, resource. What's this one? lose. First program. Let's see if I can grab this. Put it in here. Open. Download. View comments? Yes. Still no such luck, but whatever. Search for current module, enter modular calls. I guess it was the right one. Let's just go exit, C exit, go up to the call above it, and that's not it. We have another C exit. Yes, we do. Let's call. Well, that's not it either. Exit. There we go. Okay. You know what? Let's analyze and then see if our comment comes back. No. Alright, still no comments, but whatever. Daniel Correa. Yes, another stream. Let's go to search for current module strings somewhere in here and analyze module. There we go, and we were up here. And I had put a damn comment somewhere in here where I said left off here. Now let's find out where we left off. So 0f, and here's our code that we started. We had our lookup string. So let's go into here, see what we see. Okay, 10, 0. Man, I shouldn't have taken a break for so long. And okay, here we go. Add AL37. And then here, that was, so that's this portion. And then we don't yet come, oh, here's that C move A. Move if above or equal. So this was the, where is that? OX12. Add 30, move 12, compare 9, add 30, else add 37. Compare EDX, EBX, jump down here. Else we jump down there. And yeah, so we left off somewhere. I feel like we finished this, so let's see. We've got 37, move 0. Push position greater than 9. Okay, yes, we're storing those. And then let's just see, does this end here or here? What is this doing? Move ECX, EX with 10. What is this 10? Was that the length? I don't really remember. Move 0. we can get here somehow too. This is 30, so this is still the loop, obviously. And then we had an indexing, I remember that. Now how do we get here? That. This can get there from there. I think this is the indexing portion. I want to do something I haven't done before and see what happens. Open. Oh God. Hash algorithm. I wonder if we just rename it to be lowercase, if it will work. Worth a try. I'm not sure this is the same one or the right one either. Left. Wait a minute. Okay, yeah. Let's see if we rename this to be lowercase. If it makes any difference. I know it does with the 1337 files, so. KeygenMe1, and this is old, or the new.new, and this is one that it just tried to overwrite. Let's open. Comments. Damn it. Yeah, that doesn't work. So, back. So that didn't matter at all. You know, I wonder if it's because we're elevated. It opens elevated automatically. Do I have somewhere else? No? Wait, you know what? Hold on. I may have done this on my computer outside the VM, because I recall I was working on the VM. Recent files. Don't think so. Open. Downloads. KeygenMe. View. Comments. Comment. What the fuck? Bunch of calls and shit in the comments. Which is kind of cool. But not what we were looking for. Okay, well, let's just do it again. Oh boy. Actually, I am going to, real quick, reference my video. It's my video. youtube.com, not whatever that is. What? Oh, reverse, it's an ad. Got it. Fair enough. What? Alright, we should be able to go to... God, watching ads on my own videos. It should be like, oh, you're logged in as you... Oh, I'm not logged in. Too bad. Okay, we should be able to go to the end. And I should have a note, a little comment that says, left off here. Ta-da! Okay. that's what I thought. We were done in that function. So we're back out. Search for, find reference to, you know, it's 15 minutes into the stream and we're doing nothing still. I love it. It's great. For module reference string. Access granted. Should work. And this is just below 14A2. 14A2. If there's a comment here, I'm gonna be pissed. Okay. Left off here. And this should be an assembly implementation of modular division. So let's get this back over where it belongs. It's not. Oh, lose code. Okay. Great, welcome to the stream now that we're set up. There we go. So we left off here. So we did this call. Ta-da. We figured it out. We don't need this breakpoint. And after that, we got this to where we have now a little JavaScript function, which if we have a browser or a terminal or anything, we can type that in. And then we should be able to go mkey, oops, fjlj, fjlj, which I don't think any of those are in it. So let's go gva123. And we get eha234. Great. So it's mapping those to where they're at in this based off of some math. So we got each input of our key. We look it up in here. We take that. If it's in there, we store the index. If it's above 9, which is the letters, as its position in letter form. So yeah, it won't actually be these letters. It'll be, you know, this will be 10 plus 3, 7, which would be A on that. Anyways, you get the point. It'll be the letter corresponding to the position, and then down here will be the number corresponding to the position. So 0, 1, 2, 3, 4, blah, blah, blah. We're storing those, and then we're spitting those out. So we look up G. G is here. It corresponds to an E, right? Obviously, it's not an E. And then from there, we are also summing the positions that we found. If it's not in there, we're giving it a position value of x12. Yeah, so that's where we're at. And we know, well, now it's been so long since I wrote it, I don't really remember, but we recall partly that there's something to do with XOR. And I believe in here is going to be a assembly implementation of modular division, which is actually very easy because you have div. Now, you know what? I am going to fire up Ollie if we have Ollie on here, and I know that we do because I installed the Flare VM software, which comes with everything. Disassemblers, and Ollie's not in there. Debuggers, Ollie's right here. Ollie debug 2. Ooh. Yeah, let's do it. Yeah, it's fine, whatever. Oh, you better find that because that's the only reason I'm starting you up right now. So let's just open. Sometimes UAC is annoying. KeygenMe 1. Oh yes, Ollie has to analyze everything one line at a time. And start up with absolutely no highlighting or anything. That's just fantastic. Appearance, highlighting, jumps and calls. And let's go search for all strings. It always does that weird thing, and everything's too damn small. You probably can't even read the screen, but that's okay because keep too long. Well, that didn't work out. But enter a key to gain access and Control A. Now, of course, analysis is just worked, but right here's our call. And div, let's go help on command. Ollie does this correctly. Now you can't see that. Let's go options. No. Yes. No. Appearance. Fonts. OEM fixed font. Change. Bring that on up. That didn't do anything. Here, font 5, 6, font 7. Appearance, font, Terminal 6, 7. Okay. Appearance, font, a little bit bigger. Appearance, font, 6. There we go. That's readable at least. Okay, so divides the value in register pair EDX EAX, so it uses two registers. Treated as an unsigned 64-bit number by the contents of 32-bit register ECX. Quotient is stored to EAX, remainder stored to EDX. How convenient. So we have a pair, we're going to divide it by something, our remainder is in EDX, our answer is in EAX. Obviously, we're only curious as to what is in EDX. Result is truncated towards 0. Flags after this operation are undefined, so this has no bearing on flags. So flags, of course, are your little guys over here, now that we can see the registers again. So we have div ECX. We're going to divide EAX EDX by ECX. Answer in EAX, remainder in EDX. So what happens with EDX is my question. And is this even part of it? Of course it is. So this is all going to be, once again, like stack cookie shit until probably right around here. Oh, no, right here. Move ESI, ECX, move EAX. This is probably going to be our first moderately interesting thing. And then you see we have clearing out EDX, so zeroed out, increment EAX, move into frame pointer, or the base pointer, base of the frame pointer, minus 18, 0, put into ECX a 16. So EAX at this point is going to be whatever this is plus 1. So we're grabbing some value here, putting into EAX. We're incrementing it by 1. We're going to divide by 16. So let's see what that does. Hit run. Let's see which one's running. And let's enter a key to gain access. Let's do GIV123. Enter. Alright, so move EAX. What's stored at ESI plus 60? Well, what's there? Follow. Come with me and you'll see. Anyways. Alright, so we have an 8 there, but how the f did we get an 8 there? What is this 8 and where did it come from? Well, we don't quite yet know. There may have been something else going on, because what is this 8? We see our key is right here, EGH234, but what the fuck is this 8? Well, let's not stress out about it yet. Let's see what might be going on. So we're going to move 8, or 38, into our little address there. Oh, wait a minute. We know that it was using positions before. Let's count to E in this string. Is it 8? I doubt it, because 8 would be less than 9. So we know that it's not that. What is 8 in? 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 is a 9. Do we have a 9 anywhere? No, we don't. So still no bearing on what that might be. So we're going to clean out a variable, increment EAX. Now it's a 9. And then we're going to move to here. Let's follow this in the stack if it will let us. Of course not. So we'll do it the hard way. Follow EVP. That minus 18 is right here. We're going to make that a 0. Of course, we see now that it's a 0. Move into ECX, that's 16 we were talking about. And now minus 14 is going to be here. Going to get an F. Oh, EVP moved, so. Well, our stack moved, so EVP. Now EVP is there, and minus 14 here. That's not, oh, no, right here. This was where we are, and that's where we are now. I was looking at the wrong spot. I was looking at minus. You guys probably saw it. I didn't. Now we're going to divide by ECX. All right, let's do that. We're going to divide 39. Not sure where it came from with ECX. And we got 2. So we're going to push 0. Okay, cool. Then we're going to push this address. What the f is at this address? Let's see. Follow and dump. Let's select dump 2. Dump. That. Alright. Don't care. This is grabbing our key. Putting it into ECX. Oh, you remember our sum? Let's do something here. Let's do console log sum, because I think that we just used our sum to calculate a value. Sum. Let's go like this. Node's probably going to complain. Key, GIV123. Sum is 56. GIV123. Sum plus position. Oh. Yeah, that's correct. 56. Did I miss something that was done with that sum? Well, let's carry on. Okay, so we've got our key. We have some value that is now 2. And we're going to move to EVP minus 30, EDX, which is our remainder, value of that, which is D, or 13. And that's going to be there. Okay, EVP is clearly not where it's at, where it said it was at. EVP, oh, I didn't put it on EVP. Doesn't help if you don't put it on EVP. Okay, minus 30 is now D. Minus 28 is going to be a 0. And that looks like looks like ASCII. It is. The first 4 characters of our code, and then our second characters there. So 20 minus 28 is a 0, so that space is now no longer our key. It is now invalidated. You guys are so talkative this time. Oh, wait. Live chat. There we go. Everything. Hi again. Oh, no, I could see this before. Weird. Okay, so now we're going to do a call. Is this an important call? We don't know. Is it doing... Oh, it is a mem move. Let's see if we can do without it. We're keep trucking on here. See what we can glean from what we have. Move EVP minus 4, which is way down there as 0. Move EDI, some random crap, which happens to be negative 2. Negative 5. Move EAX 6. Follow that in the dump. It's just a 6, which is length. We recall that from before. Here's our random 8, which 3, 8 is definitely not our sum unless we did something wrong with our sum. But what was our sum? It was 56, and that is going to be not there. Oh, wait, I'm retarded. And I mean that in the best way possible. But 56, guess what the hex is? Derp. So yes, this 3, 8 is our sum. So we used our sum, and we divided it by what? Okay, so we had our sum, put in EAX, we incremented it by 1, and then we divided it by 16. Okay, so let's write that down. We have sum plus 1. Really, that's all we can confirm, because we don't know if we're using the quotient somewhere or if we're using the remainder somewhere yet. So let's continue on and see what we find out. So move into EAX, a 6, which we know is our length, so we're probably going to go into a loop. So I'm going to put for let, I wonder if this will work. C of stored that's going to be each character of this. I'm making an assumption here. It's each character of our calculation. Here we have something. Let some value equal beginning this. Not sure how used yet. Awesome video, but it's too late. Tomorrow I'll watch play. Hey, I understand that, and I'm kind of dragging on. We're picking up the pace now. I either relax too much, or it's too late, or maybe just a little bit too much of that. I don't know. Maybe not enough of that. Probably not enough. Alex, you with me on that? I know you are. You don't have to work tomorrow. What are you up to, anyhow? And yeah, we'll get you some Final Cut. No worries there. It's just a matter of getting us together to do that. If you're still here, I'm sure you are. Probably one of the 4 people. Anyhow, so we're gonna move into that. Our value, this is going to become our counter. I wish we could like call it that, like put a temporary label there. Anyhow, but so far, I don't. If you can, I don't know how. Okay, so we are now moving. What the just happened? I don't know. Anyhow, we're now put that into, so we grabbed our length, put it in EAX, we took that and stored it in on the stack right here. Now we're going to move to EAX EDI, and EDI holds -5. I already know what this is. I remember now. I remember what -5 is used for. It's for this stupid loop. We'll see what we can do about getting around that. So, compare EAX and EDI. I didn't move it, sorry. Compare. I was thinking ahead on what this was, and then, yeah, so we're going to compare our length with -5. We're going to jump if it's less than or equal. Well, our counter, not our length, our counter. And if it's not, then we're going to go into this. So it's 6 is definitely not less than or equal to -5. We're going to move to ECX, this one here. What's stored at ESI plus 40? Let's just go for it. We know that that is a 6 because we stored it right here. Well, we didn't store it there. We recalled it once before. That's our length. It's not our counter, it's our length. Our counter is actually at 38, which comes back into play, I'm sure. Right, yep, right there. Okay, so now we are going to XOR EDX and EDX. Okay, we're going to clear that out. Make sure it's empty, which is, of course, here on your registers. And you guys can see the cursor. Okay. Load the effective address of ECX plus EDI into EAX. So ECX is that, EDI is that. So we're doing math with load effective address, which is a very common thing, and I do it too. If you want to take two values and store the answer somewhere else, it's very easy. 3-byte way to do it. So we're going to do 6 plus -5 is 1 and put it in EAX. And there you go. We have EAX. Now we're going to divide the pair EAX EDX by ECX. EDX will be our remainder. That's weird. So 1, our current position, being divided by our length. Of course, we get 0 and a remainder of 1. Hey, it's G-Master. How are you, sir? I am doing okay. I am awake still. Do work tomorrow. But we're going to get at least another 20 minutes. We're going to finish this function. That's what we're going to do. And I am doing good. So we're going to compare ECX and EDX. Now, EDX is our remainder. ECX is our length. Right, we're going to need to write this stuff down. So we're in a loop. We don't know what's going on, but we have our length and a counter. So this is the wrong type of loop. We're going to need to do for let I equal 6. We started with a counter equal to our length, so That's not going to work. It's going to be stored dot length. Then we want to do, while I is less than, I'm making an assumption here. Okay, we have our stored length. Start with the length. We do -5. So we'd be 1, 2, 3, 4, 5, 6, 7. No. We should know the conditions. Less than or equal to. EAX was right, stored.length, and then we want to make sure that we are our length, no, our counter I is less than or equal to, at this point, EDI was -5. Less than or equal to -5. Let I equals stored length. Oh, this was not, no, we went I equals -5. Well, no, we didn't. Yeah, it was stored dot length. Should have wrote this down before. It's night. It is night. Oh, gotcha. Night. I understand. So as long as the length or I, which is starting out as the length, is greater than or equal to -5, I minus minus? No. Plus plus. I see what's going on here. We'll see in a minute. Okay, so we have some loop with some assumed, things, but we can modify those later if we need to. And then we do a what did we do? We put our counter yeah, that's helpful. So counter, and then EAX was given the addition of our counter and -5, and then we divided by ECX, which was our counter. So 1 divided by 6. So we have a let some var equal I divided by stored length. That wasn't our counter anyways. Stored length. Counter is 3.8. Remember that. Yeah, it's EBP minus 3.8, not ESI plus 40. And is it stored length? ECX is our length. We're dividing by it. And we're dividing not I, but ECX, which is our length, plus the negative 5, I plus, wait, what? Store dot length. Is that correct? Because our counter's here. Compare EAX with EDI, and EDI is -1. So our counter starts out as our length. Boom. Our compare is -5. We don't yet know that we're incrementing or decrementing. Checking to make sure that our counter is less than or equal to -5. As long as wait a minute. Is that backwards? Could have that backwards. I would not know. Let's see. Do we have Ollie still? Do. Where is it? So, yes, it's still open. So let's go compare. Divide. Yes. So. No, here. No, what the? Oh, I see what I. Copy address. Go to that address. And help on command. Jump if less or equal. If flag S is signed and overflow are different, or if flag 0 is. Okay, we knew that. Okay, compare. Here's the examples. This is why it's so good. What are you working on? We are reverse engineering the algorithm that I wrote weeks ago, and I don't remember, for the KeygenMe challenge that you can find on forum.give.academy. Try it today. Anyways, so compare A, B. Jump will be taken if A, treated as a signed number, is less than or equal to the signed B. If this was jump JBE, jump it below or equal, that would be unsigned. Pro tip. So if A, so first one is less than or equal to the second one. So if our first one, EAX, which is our length, not our counter, our length, is less than or equal to -5. There we go. So yes. Do this while I is less than or equal to -5. Or, I mean, the condition is until it's greater than -5. Good lord. Like we could do -5. Or no, I is less than. Anyway, we're going to leave it right now. So now we did this division. And we compare. So this is some variable which was EAX, EDX, which EDX was 0. EAX was ECX. ECX was our length. EDI was our -5. So -5 in our length, which is our I plus -5. Oh, I see what's going on here. So we'll do -5 equals I equals -5 while I is less than or equal to stored length I plus plus. Then we can do some variable equals stored length plus I divided by we don't know if it's divide or mod yet, so I'm gonna guess it's mod because I kind of recall what this would be, but dividing those wouldn't really do much unless you were doing something with random numbers. But if you want to put constraints on something by a length, say the bounds of an array, you would do mod. So I'm going to say that mod stored dot length. So far, that's what we have. We need a closing parenthesis here. There we go. Okay, so we compare ECX and EDX. Now, EDX is our remainder. What do you know? We compare our remainder with our length, which tells us it's mod. So we are going to, if ECX, our length is below or equal to our remainder, we should jump, or I read backwards. Right. No, I read it correctly, but we should jump if that's true. But if our length is below our remainder, then I said we should jump. Anyways, so it's not, because 6 is not less than 1. So we're not going to jump. Instead, we're going to compare what's at ESI plus 44 with a 10. And what's there right now is an F. So let's follow and dump that address. It's an F, and we see that that is down here underneath our stuff and junk. So here's our key, and then we have this F, which, if we recall what this value was, we missed it, didn't we? So let's go back up here. We have increment div ECX, and then 30 EDX. 30 is not being used here yet. ESI plus 44, where did this come from? Some variable. Well, we're not. Isn't that where we put that before, though? 7B35. Anyways, we're not going to think too much into it yet, but this up here, where we did this first division, this EDX is a remainder. It's being put here. So this 30, we're going to XOR by that. So this sum value becomes an XOR key. I'm glad you got back into it. Well, of course. Just been swamped with homework. So sum plus 1. And then we divided that by, does anyone remember? Because I sure as hell don't. Divide, no, not that one. Divide ECX, so 16. And we used the remainder, so we'll do mod 16. Mod OX16. And there we go. Stored push. We did that. That will start watching soon, I'm sure. Of course. Okay, so we're here, and that's gonna be. So now we have some XOR key. We're about to get to where we use that. We're in some type of a loop where we have a sort of a weird ass loop going on here. I feel like we don't really need all of this, but yeah, we're gonna leave that. Hey, freaking cat, what's up, dude? Okay, so let's come back on down here. We're comparing this value with 10. Not too sure why at this point in time, really. So we'll probably find out. F. What was this value? Now that we know this, it was 3.8. And what did we do? We did +1. So let's go decimal. +1. I don't know why I went decimal. Hex mod 16. D. So definitely not our XOR value. But I don't even see our XOR value. Unless we did something else to it. Oh wait, no I can't. Oh. Dr. Evil in the house. You're crazy. Alright, well, we're going to compare that weird ass F, don't know what it is yet, with a 10, don't care. It's probably some type of a length used for something, and it's obviously used in a loop here because now we're going to load into EAX our key from the first half that we did, and we are not moving quick, but we're moving quick. Now we jump if below, so that F is below 10, because 10 is not 10, 10 is 16. And here we say move SX EAX, the byte at EAX plus EDX, which is a super fancy way of saying at EAX plus EDX, which currently is 1, move that 1 byte into all of EAX, not just AL portion of it. So we're going to see this E pop right here. F8. Boom. Did I say E? Apparently we're on our second character. Oh, wait, we're at +1. We didn't start at the base. We started, the base would have just been there, but we're at the counter, so we're at +1. And we got that by saying stored length plus I mod stored length. But is that correct? Is that correct? I don't know that that's correct. Let's exit this because JavaScript modular division is broken, and I'll get into that later. And we have 6 plus -5 is 1. Mod 6 is 1. Alright, so it's, yeah, it's within that range. Of course, if we would go to 7, it would wrap back around. Oh, okay, I see. See where we're going at with this. Alright, so we've got that second character. We're skipping the first one. Alright, and now we're going to go, so we're going second character, third character, fourth character, fifth character. But wait, the fifth character minus -5, 0 mod 6 is 0. Wouldn't that be first character? So we go first character, third character, or first character, second character, third character, fourth character. Well, sorry, excuse me. 0th character. So 1, 2, 3, 4, 0. And then what? 1, 2, 3, 4 because 5? We'll find out. Because our constraint here is less than or equal to stored length. So that is going to go all the way up to 6. And we're going to be adding 6 to 6 mod 6. So 12 mod 6 would be 2. So yeah, it would wrap back around a few times. We're going to do more with this, I guess. Move to ECX of 16. All right, so in EAX, we have the first character. Okay, cool. Moving to ECX of 16. All right. Now we're going to XOR EAX by that XOR value. So we need some type of an index because we are now working with a variable that holds our first character. So that was based off of this, so we don't really need let sum var equal, but we'll leave that and we'll say stored that. I'll be home soon. Keep up the teaching, brother. We need more people sharing knowledge. Oh, of course we do. Everybody should share knowledge. And where'd my stream stats go? They keep flashing away. Need my time. And we're at an hour. Shit. All right, this one's going to go a little bit longer, but I promise we're getting there. So, let's see here. Yes. So, we're looking up the character in our stored based off of this math. We saw that. And then what are we doing with that? We've got ECX in 16. We're not sure what that is for yet, but first we're going to XOR by this XOR key. So now we'll go Control C, and we are going to XOR that with this. Okay. All right. Let's see where we're going here, I think. What's 16 in decimal? 22. Okay. Which it probably says it. No, it doesn't. Surprisingly, usually it would. Anyhow, I could have done this too, but no, I'll take the hardest, longest route all the way around because you know that's the way I like it. I'm just kidding. So we're gonna XOR that. We got that in there, so let's hit F8. All right, so we've XORed it. We've got a 4A, which is a J. And what is CDQ? Oh, CDQ. It's a time for the learning. CDQ, help on command. Convert double word to quad word. Signs, extends, EAX to EDX EAX. That is, if EAX is positive, its most significant bit is 0. Yeah, right. That's how you define that a word is, or a number in hex is positive or negative. Its most significant bit is 0 or 1. Then EDX is set to 0. If EAX negative, most significant bit is set to 1. Then EDX is set to all Fs. However, it doesn't change any flags. So in here, we're going to convert a D word to a Q word. And we're going to extend EAX to EDX EAX, pair. And we can see that where right now EAX and EDX are doing this. This is either going to become 0 or all Fs. Well, this is positive, so it's going to become 0. We hit F8, it's 0. We don't need to bother with that. Now, idiv ECX. What the f is idiv, and how is it different than div? Well, let's ask it to Ari. Ari is what I call Ollie when he's sleeping. Divides the value in the register pair EDX-EAX treated as a signed 64-bit number by the contents of 32-bit register ECX. Quotient is stored in EAX, remainder in EDX, blah, 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 blah. So, the difference is this is signed. That's it. Still got your answer in EAX. You're still dividing by whatever you say after it, and your remainder still goes to EDX. So let's see that. So this is likely another modular division. We'll have to see. Does it do something with EAX after, or does it do something with EDX after? Now this being an 8 and this being a 3, both could be relevant. Now we compare what's that? ESI plus 10 with EDX. EDX, of course, is our remainder. So we're comparing our remainder with 22 or 16. And it is not below or equal. 22 or 16 is not below or equal 8. So we're not going to jump. So we're comparing it with 22. Why 22? I don't know. I have a guess based off of something I just saw, but we'll find out. So now we're going to compare what's that ESI plus 1, 4 with 10. 10, of course, being 16-ish. Swear it's 16. How tired am I? Yes, it is. Okay. Like, base 16, 1, 0 should be 16. Or 2 in binary. Anyways, we're comparing it with 1F. Now 1F is much bigger. You'd have to add another 10 to that. So 1F and 16, 31. All right. 3-1. What do we remember about 31? Not a whole lot. So we're going to compare this value, this 1F, with 3-1. And we're going to move into EAX. What's that ESI? Now ESI is this key here. And my thought or my idea was, well, this key has a length of, so here's 9, 10, I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22. It's 22. So it has a length of 22. Likely, we did our division here by this here 22, and we're comparing with 22, the modulus of it. Because this was stored there. So we are doing something to the effect of this whole thing. I'm looking ahead here, so yeah, we'll get to it. I just don't want this to be too confusing. We're doing something mod 22. Something mod 22. Now, moving to EAX, our ESI value, which is our key. So now what, or not our key, but our alphabet that we defined up here as lookup. So we've put lookup. It's come back into the game up there. All right, so now it's going to recall this compare and say jump it below. Now 1F was not below 1, 0, so we're not going to jump. Now we're going to move into EAX, the D word pointer that's at ESI. We're dereferencing. That's all we're doing here. We're dereferencing. Boom. Now you know where it's at. You're not an address, or you're not a pointer to an address. Now you're the address. We're just dereferencing this. But why the f it couldn't just dereference itself? We just moved it there. Like, oh, it was looking to see if it was passed by reference or by value. So it was basically saying, am I a pointer or am I not a pointer? We went over this last time too. And then here it said, basically, it would have jumped here. It would have not dereferenced ESI if we jumped here. Right, if we would have jumped here, it wouldn't have had it would have already been dereferenced or by value. Since we didn't jump, it said, hey, I'm by reference, convert me to value. Now we're here and we're gonna move to DL, my favorite register. Well, my favorite nibble. DL, the byte that is at EAX, so we're looking up our key, EDX by this value here. Which is the remainder after doing a division by 22. So now, like I said, I was looking ahead a little bit. This makes a bit more sense. So we have all of this, right? Because that's what this represents. We're still working on that same damn number. It's all that math. Then we divided it. And then we used its remainder, which just means modular division, by 22. And now we're looking it up in alphabet. We're going to move that whatever character. So now we go look up like this. Excuse me. All right. And of course, we need one of those. I don't know that we're done yet, but we will need one of those. Okay, so we're looking that up. Got a 9. We looked it up. It's over here. We moved to ECX, a fucking 0 for some damn reason. Then we move that, which we just calculated, to EBP minus 2C. Now, we hadn't seen this anywhere else yet. Guess what? Variable time. And look, here, we're going to push that somewhere. If we ever get there in the same context. We may not. Now, is it referenced anywhere else? No, it's only referenced here. We're inside a loop. It's building our string. Here it's going to compare it with some sort of pointer, which is 1F, or just F. I don't remember, but we'll find out. Oh, that one's F. Anyhow, let's see. Let's go on. So we're going to move that into, and of course, we like to watch things built real time. We're going to move that into right here. Boom. It's a 9. Oh, it's alive. And then we're going to compare ECX 0, which we moved from this, which was a 0, so some sort of county thing. I'm not sure what. And then, yeah, we need, oh, look, we're going to do some math and then store it. So this is definitely a counter. So now we compare that with F, or 10. No, A is 10. F is, 16. No, it's not 16. It's 15, technically. 10 is 16. 8, 16. 8, 16. God. We can do binary all day, but the whole hex decimal, I always get tripped up. Okay, so ECX, we're comparing that counter with 15. I'm going to second guess. Yeah, just believe, Frank. Just believe. Okay. Now, jump if above or equal. So if we're above or equal, we're going to go here. We're going to push and do some stuff. Otherwise, so our counter is not above some ungodly value yet. Now we're going to compare it again. Now we're going to compare something else. Wait. All right. First was our counter with it. Now we're going to compare it with 10. Just weird. Where is this even used? What? What is this? Oh, it's right here. Anywho, comparing F with 10, that's still not making sense to me. Where did this damn F come from? I don't recall where 15 would have come from. Anyways, let's do the comparing. Now, you see here, we're going to load into EAX, ECX, which is our counter, plus 1. Boom! Math done in 3 bytes. And then we're going to store that. We used it here. Now we're going to store it. Now we know that it's 1, and we can recall it later when we move it up back into ECX here in our loop. And now we're going to load into EAX, or not WhatsApp, but EBP minus 28. We're going to put that there. Boom. What is this? Follow and dump number 3. Oh, how convenient. Oh, okay, so that is the address of our key still. We just apparently replaced that with a 0. It's been mangled a little bit. That's okay. So C move AE, comparatively move if above or equal. So this compare, C, carry? No. C move A, basically based off this condition, either put this into EAX or leave it. Let's check Ollie because it's less confusing with wording explanations like that than I am. There it is. Help on command. Conditional move if above or equal. If flag C carry is 0, moves contents of 32-bit memory at location to 32-bit location EAX. Otherwise does nothing. All flags remain unchanged. Instruction is now supported on older processors. So here is our example. We have compare AB, C move AE, X, Y. X will be assigned the value of Y if A, treated as an unsigned number, is larger than or equal to unsigned B. All right, so we know that if this F is larger than this 10, which it's not, it's 1 less, EAX would become this, what's stored here. Now, what is stored there? It's the same damn thing that we just put in EAX. So, I think this is another like by reference dereferencing, because these, remember, were stored in objects or classes. So it's not going to change. Now it's going to move the byte that's in DL to another address. Didn't we do this once before? DL. Click DL. Dump 2. 9. Not it. 1. There it is. 9. EAX plus ECX 0. Oh, we're legit overwriting it. So check this out. Boom. 9. We are storing this. Now we're putting it back into the class. So yes, that's what we're doing. So not only did we calculate it here, but now after we've calculated it, we're going to store it back in the class. And then we're going to move the next byte, G, a 0. Hey, we're working on this one next. Let's zero it out. That's what it says. And then we're going to jump down to here. increment EDI, and this jump to here is just, let's see here, push to move, push, X call. Yeah, this would be like mem copy or some shit probably. Yeah. So if it needed to do it that way, like it could. But anyhow, now we're going to increment EDI, and of course we remember that EDI is our I. It's our iterator right here. I is -5. We're going to increment it now. We're going to make it -4. Cool. So now it's -4. Compare EDI with what's at 38, and that of course is our length, which is 6. So we're comparing our length with its 6, and we're saying, while I is less than or equal to the stored length, its negative number, it's going to be for a little while. Continue on to the loop. All right. So, we made it through the loop. I don't think we missed anything. Sum var equal lookup. Now, this just won't do because this is like in a loop. So let's go x sum var equal blah, like that. Actually, let's just make this one a string like that. And let's do sum var plus equal. Now, this might look pretty contrived, but really it's just to stay within the bounds of everything. So here we have stored length plus I mod stored length XOR blah mod 22. It's just to stay within the lengths of stored, then do an XOR, make sure it's valid within lookup by 22, and then add it in. So we're now taking our output from this one, XORing it with this key that we made, which is just our sum plus 1 mod 16. We do know how this is used. And we're going to loop through this, and then we're going to console.log sum var, oh, not quotes, sum var. Now, those of you that have ever written JavaScript may see an error 3 that have just been driving you mad. Quit node. Actually, I'm going to do this in the browser. Just be a little bit easier. Hi there. It says, I'm sorry, I don't read Russian. I see that it starts with BAC, but of course in Russian that might not be, because like R's are, I don't know, I don't know Russian alphabet. Vasily. Hello there. Hope I didn't, Vasily? Wouldn't butcher that too bad. Anyways, thanks for joining. We are reverse engineering some code that I wrote a while ago for a keygen. We're getting close. Real close. Okay, so now let's try, what did we call this? mkey? mkey. Yeah, I've done some testing. GIV, 1, 2, 3. And we get out some value. Now, that's all well and good, but there's a problem. And that problem is that, watch this, 5 mod 6, 5, 6 mod 6, 0, 6 mod 5, 1. Now, if we do -2 mod 6, we get -2. That is nowhere in any world correct. Of course, all the mathematicians in the room are going to go ape shit, but let me show you. -2 mod 6 is 4. Gotta wrap it back around, guys. A lot of languages do this. I don't know why. I think Python's the same way. Let's see here. Exit. Python. Oh, that was slow. -2 mod 6. No, it's correct. It works, but JavaScript is broken. Even in the browser implementation, it's broken. Control D? Yes, okay. So let me show you how to fix that. So what JavaScript is doing is legit just -2 divided by 6, and it's getting confused. It doesn't know, like, it's like, well, the remainder, what do you mean mod by a negative number? Which, yes, there's just a method to it, and it's pretty simply put. You do the number -2 mod some other number, right? You do that, and then you add what you're modding by, and then of course again you mod by that number. So they're doing the first half of the step, and if we do modulus of negative numbers, modulus of a negative number is found by ignoring the minus sign. The modulus of the number is denoted by writing vertical lines around the number. Note also, modulus of a negative number can be found by multiplying it by -1, since, for example, so we could implement this another way by just going 2 mod 6, but that didn't work. Ignoring the minus sign. The modulus, see, it's controversial. It is denoted by writing vertical lines around the number. Note also the modulus of negative number can be found by multiplying it by -1, since, no. Let's see here. Modulo operation with negative numbers. See, somebody else is onto it. 5 mod 3, mod 3, 2, -2, and -2. Does that work? Like if I do mod, if I put that around it, no, that doesn't matter. What if I put that around it? No, that doesn't matter. Okay. Go away. Can't read. Requires that when A is represented, A times B plus, yes, we got that. -5 divided by 3 is 1. -1 times 3 plus. Yeah, so that's the math that I just did. Okay, but like I want not programming, I just want math. Read this one. You guys don't care. You can look it up. That's some homework for you as to what the math behind it is. But long story short, JavaScript implements it wrong because everyone else does it right. And that would throw us off for days had I not known that about JavaScript. So these mods with this negative number that we have here, we will not be able to implement like this. Instead, we will do this. I've written a function before. Mod. Now, yes, we could prototype number and do it that way, but you'll probably run into problems doing dot. So instead, we're going to wrap these like this. This is terrible, but we're going to do it. So stored. We're going to do mod of that, comma, that, and mod of that, comma, that. That should do it. Now let's see what happens when we do that. M key of GIV 1, 2, 3. did we really just get the same answer? Believe it. Nine two CME 7 9. Yeah, we did. Is something wrong? I is -5. Well, I less than stored length. I plus plus. It seems a bit long. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that's correct. Let's see here. Let's go like this, because yeah, these 7s are throwing me off here. I think we're going 1 too far out. Okay, so M key. It's legit the same damn thing. Oh, no, yeah. Yeah. We have 1 less 7 now. It should be... One, two, three, four, 5. Is that correct? I don't think that's right. Let's see. I equal -5. I is less than stored length. I plus plus. Some var mod. Look up the mod of the value that is at stored of mod stored length plus I by stored length, then XORed by our XOR key, which is just our sum plus 1 mod 16, sum var equals blah. Okay. I don't think, well, yeah, we don't have to worry about this. It's just the negative ones that we need to worry about. Would that be causing any issues? Let's see, where's this ending? Have a good day. Your video is very interesting. Thanks. Have to go. See you. Well, fine. See ya. Yeah, I am kind of at that rambling point where I believe we've got this function done, and I'm just kind of testing it. And we are at the hour-and-a-half mark, so got to wrap it up. So that ends there. That is correct. That ends there. That is correct. Mod of stored length. Stored length. Only reason we're doing this is because this will go negative. When we do or it could go negative. All right, so let's do that and see if it's different at all. If not, we're just going to assume it's all correct and working fine. Oh my. Okay, I could have typed it. Yeah, undefined. What the f did I just break? Okay, stored length plus one. Oh, comma. Wait, no, that's correct. Mod that. Oh, that goes there, not there. Okay, we're gonna assume it's correct. Can't confirm. Can't confirm. Hi from Argentina. Well, hello, Argentina. I know I'm up late. Anyhow, so let's come back into here and we're going to follow this out a little bit more. Like, yes, we just got to the end of that loop. We covered everything. Now, if you understand the whole loop the first time through, then you don't have to go back through it, right? Right. So we're not going to go back through it. This is going to go up there. We just want to make sure that if we were to jump anywhere else, we're not going to land anywhere else. Let's undo that. We have some var. Now, how is some var used or what happens with it? And we know that we're storing it here, but we're also storing it here. Now, I'm going to hit F9. We're there, and oh, why didn't I think about confirming it here like this earlier than fucking around with that code? Because the whole time it was working fine. We should see out in our browser that same thing, except I closed it. So let's make this a bit smaller. Go it over here. Inspect. I didn't think I closed it, but apparently I closed it. M key. All right, is that the same? 92 CME 792 CME. Great. So we made the same thing that this made. Our algorithm is working for this M key. Now, what happens with that? So F8. Now we're going to load into EAX. So wait, we just got done making it, and it's in EAX, but it's also stored here, and it knows where it's at because that's where it's at. Now it's going to load into EAX this value, which is the same damn thing, only down there at the good old class store, I bet. If we go to the class 6.4, yes, so it's pulling it from the class. So we're going to compare ECX with EAX. Now, what the fuck is ECX? Follow and dump. Well, it's definitely not a 0. So I think this is a reference dereference thing. Compare dword. Yeah, it's definitely that whole F and 10 and blah, and push dword. Because we're dealing with the class, and then cmove E. Nothing. Push EAX. Call this, which memmove is going to copy it on over wherever the hell it needs to. We don't care. Move to EDX. Apparently that F that we still have yet to understand what the fuck it's for. Compare EDX 10. I think it has to do with just the fact that we're in classes and it's like a size for whatever is defined as one of the sizes in the class of the structure or whatever. Basically, when you don't see something and it doesn't make sense, see if it's relevant or if it's just it doing something else or setting up for something else that is going to need to do. For example, we were able to do this and get this without even knowing that any of this was in classes. Like, yeah, we see it, but we don't have to pay attention to it. It's not like the assembly knows it's there. It's just, the class is just another memory space over here with these things. It's a way of organizing data. So, compared those, jump below. F is still below 10. So we're going to go down here. I'm guessing it's for compatibility on processors that don't have CMove AE. I can almost guarantee it because when we don't, where we jump this is where this is at, and it's not compatible on older processors. Thus, your program wouldn't work, and the compiler, knowing that, is going, oh, by the way, do this if we need to where, or it's going to throw an error. Oh, I guess if we got here, it would throw an error if whatever this compare blah. Yeah, this is all processor stuff. So now we're here. Move ECX. This is going to be our stack cookie stuff. Boom, 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 boom. Put the frame back. And now it's doing a call, which compare ECX with that. Band. What the fuck? Copy address. I want to see. What is BND? This is news. Wait, what? Oh. Well, we can just paste it anywhere. Don't keep size. Alright, let's do a binary. Binary copy. Oh, okay. So it's just one of these. Wait. Oh, let's fix that. Edit, fill with nopes. Edit, binary paste. I forget that with all you gotta paste like that, so. Up on command. Jump if not equal. If flag Z is jump to the instruction remains unchanged, jump will be taken. Jumps to the instruction at address. What does this mean? Is this like a relative type jump? It's all security cookie stuff, stack cookie stuff. Basically, did you fuck with anything? Do these things still match? That's what it's saying. Then put that back, and return. So now in here we have EAX, and it's this. And real quick, let's go and see where is our whole access granted and all that jazzer. I'm terribly sorry is here. We have a jump to it from there. And that's our access granted. Per byte. Oh, that's access granted. Get to from here, compare 10. Message retracted. Gmaster, what? You're retracting your messages. You have the best messages. So let's follow this down real quick and see where we end up with EAX. So what do we do with EAX? Does it get stored? No, because we reference it with the class later. I guarantee it. So boom, boom, boom. Compare that with ECX. Load into EAX. Oh, look, give for KeygenMe. Move byte, that 0. Okay, C move B, based off of a compare up here. And compare, push ECX, 4. So 4, C move A if above or equal, EAX. Load into EAX, ECX, blah, 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 blah. Some place. Is this important? No, it's not. It's just mem move stuff. Move byte. to, oh look, EAX is now just give. So yeah, if you didn't catch that, what we did was basically a mem copy or a mem move. We took that whole string, took the first 4 characters, and put it somewhere else, and it's back in EAX now. Move byte EBP -4 2. Okay. Load into EAX. And since we copied it somewhere else, it's not going to use EAX. It's going to use the address that it copied it into, which is up here somewhere, but it's not relevant. It's going to come back up. The most important thing is that we know that we're using the 4 characters. So let's load in there, and now we have, boom, ours, and look, these are the same call. So let's follow this in the dump. And let's see, does it just cut it, or does it put it somewhere else? We don't really, oh, there's give. I mean, we know that it puts somewhere else. Because it doesn't use EAX, so it had to modify it somewhere. See, move B. All right. And then it's gonna do some magic. It's either gonna do it down here with this, or it's gonna do it up there somewhere, or somewhere, wherever our class data is at. So right here. So now we have the first 4 characters of our key that we generated. Compare dword pointer blah 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 blah. Load that up. Move that in. Load that up. Move that in. C move AE. So it's gonna put those 4 right here. Of course, they're gonna be backwards. 9-2CM. And then it's gonna compare. And, it's basically, can I do this dereferencing trick? Is what I see going on here. Compare 10. Compare ESI, which is 4. Boom. Jump if not equal. Sub ESI 4. Jump if not. What the fucking what? I've never seen this in my life. A no instruction that has parameters. I was not aware. Copy address. What does Ollie think it is? Ollie doesn't give a fuck what it is. It's like, I don't know what it is. It's not. It's not. Let's see. Analysis. Remove analysis from selection. Oh, there it goes. It goes. It's a no D word pointer EAX. That is crazy cool. That, yeah, I was not aware that there are no instructions. Like, is this actually going to do anything? Like, what happens if I do help on command here? Like, does it say anything? What? Genuine learning does absolutely nothing. Yeah. This form of nope is not supported on many older CPUs, right? So, and here it's like, okay, and I'm going to do a no instruction. I'm going to move to EAX, the D word pointer that's at EDX. All right, cool. Now we've got that in there and EBX. Compare that with the D word pointer that's at ECX, so give. Jump if not equal. Now we're going to jump if not equal, and down here, we're going to fucking set a byte and compare it later probably, but I think you see the picture here. We're comparing it with give. If it matches, then we would do this and then do this. So the difference is not much. Oh, here's an XOR EAX. And here's a move byte 1. Here's a move byte 0. So we didn't do that, but we'll get there. So we're jumping over that. Move to AL that. Compare AL that. If not equal. So it's saying, wait, it was going to compare. Wow. even though it did a compare, a D word wise compare, it's still going, well, wait, let's make sure and compare it byte by byte. So in here, I'm going to move the first byte and compare that first byte with the first byte over there. Jump from not equal. And now it's like, okay, all right. They definitely don't match. Set it to -1 by subtracting it from itself, and then go ahead and order that with a 1 and jump on over here and move a byte to 1 and test EAX, and EAX is -1, and then just go ahead and move that to 0. Because if EAX was 1, or not, well, it'd have to be 0. Then we would jump over this. This would stay as 1, not getting set to a 0. And if we follow this in the dump and we set it back to a 1, just manually, I think we'll get the results that we're looking for anyways. Excuse me. All right. So, did you guys catch all that? Good, great. So it's even going to go in and compare that. So if it matches right off the bat, it's like, yeah, they're the same. It still goes and says, but are they really? Compares each byte. And then if any of those don't match, we're going to land here where we set EAX to -1, and we make sure of it. And then we jump over the XORing, which would set EAX to 0. We set a 1. This is so ass backward. Jesus, compiler. And then we test EAX, and we jump over setting a 1 if it's not 0. Otherwise, we would set, or setting a 0, we jump over setting a 0. Otherwise, we set a 0, which we could have done by matching up here. That's so strange. Anyhow, let's continue and see what we find. Oh, right, by not matching up there, we set a 0. 0 is bad. So we skip all that if we can, and now it says moved EAX, that compare 10 again, more 10s and Fs. Move into this byte a 1, which has nothing to do with this other. This one's important. Where else do we see it? Right here. Compare it with 0. There you go. Jump if equal. So if it's equal to 0, we're jumping to the bad message. If it's not, we're getting access granted. So we compare with give, and then we set a value, and then we fucking set another value, and if that value, then we unset the first value. And then later we compare that value with a fucking value to see if the value of the value is valuable. And if it is, you get access. If not, well, long story short, we know that the first 4 characters that come out of here just need to equal give. And it will be a valid key. So let's find a way to do that. We know that we can give it input. And so the important part of this is done. Like, boom, we have recreated the source to create any key from any input. So now we know how to create what is being compared against, and we know the conditions. We know output first, let's go. First 4 characters of output need to equal give. Right, we know the condition, we know how to make them. So now you could go back through this math and figure out one value that does that. Or why don't we go ahead and find every single value? Now, I'm not going to go through all this code, but earlier I have prepared a little bit of code And looks like this. So this doesn't contain anything that is from this except the alphabet, which I added another character to because we know that we can force this if it's not in the alphabet to be OX12, so it's another possibility. And this is just to pick random keys. So we have a 1, 2, 3, 4, 5, 6 digit key. And then we're going to say, while the last character of the key is less than the length of this, right, 23, continue testing keys, and test key equals cnt.map. And we're going to map, we're going to have a variable called chr alpha char join it, right? So we are we're saying incrementally, starting to 0, this character here, going up to the length at this character there, incrementally map a key for every possible combination of these 23 characters. And then we say mkey, right? So I put the function in here, the one that we just wrote right up here. Test key we've generated here, slice 04. So if we put in a 4 character, 1, 2, 3, 4. So we're going to generate, right here, we're going to generate a key based off of the first 4 characters. And we're going to take the first 4 characters of that result, compare it to give. If it's good, we are going to put it into a variable called found. In this instance, we're just going to console log it. And then, so that's testing 4 character keys. This next one says generate one with 5 characters. This one says generate all 6. If any of them are equal to give, in the first 4 characters, spit those out. Now this is not optimized at all. It's just the quickest and dirtiest way to say, hey, test the 4, 5, and 6. Obviously, you're going to get those repeating each step, which we could tell it to skip, but I don't care. It runs in under 5 minutes anyways. And then down here, this is just to increment the fucking counter. So the worst way possible to do this, I'm sure. But basically, it says increment this one until it equals the length, set it to 0, increment this by 1. When this one is the length, set it to 0, increment this one by 1. Kind of like clock, kind of like a clockwork. Old mechanical clock. Yeah, it just says that. And we're going to keep incrementing this until this, until this, until this. We're just making sure that we fill them up, and then this will continue to run until this last digit equals or is greater than the length, actually. And then I put in a little time thing at the beginning. Where is the beginning? Oh, we're start. Oh, start right here. Date.now. And then milliseconds, date now, minus console log, how long it took. So let's not quite run it, but let's grab that code right here. So once I had this information, which I wrote this a long time ago, not this, obviously we wrote this together today, a week or 2 ago. But once I have this function, how can I use it to make some keys? That's all you gotta do. Can I go backwards to calculate a key? Can I go backwards to calculate the only key? Can I use its code itself to just spit out keys until it matches the same condition that it checks? Yes, I can. So we've got mkey. It's doing its thing. I believe, yeah, we haven't changed it. I do want to take out the console logs because otherwise it's going to flood the console with this crap that we don't need. because this is going to be logging the variations of the keys that work. So we'll overwrite that function, and we'll put this function in, and now we will type bforce, and we'll run it, and we'll have an error occur that says, what was the error? Cannot read property slice of undefined. What? Test key slicers are 4. Maybe we should have left a console log in there. Oh, I don't have a found. Let's just put found equals that. And then oh, this doesn't return. Oh boy. Return some var. That might be helpful. So we'll go like that, and then I didn't have a found, but we're gonna keep a found. We're gonna have a found so that this can run, and we're gonna go bforce. Now we should start getting some keys, and there you go. And did I? Console log. Did I leave in a console log? Like, what the? Why are we getting? We're getting good keys and bad keys. Console log test key. Oh, the ones that are full. Wait, found up push. Console log test key. Console log test key equals m key size. Why do we need this here? We don't need that there. That's just superfluous junk. Okay. And there's no stopping that, but we can grab any one of these. Like, say, this one. I'm just going to scroll up so it stops. 51288. And let's just close Ollie. We're done with that. And we're done with that. We're going to run this. Yes, run it anyways. I wrote it. Access granted to Givey. I didn't know it was going to do that, but apparently that is it. Yeah, so we know how to now generate every single key that could ever be, and the smallest one, which we've seen here, is 6538. Let's run this again. 6538. Give G. And if we put in S7565, any of these will work. Like we're validating them right now. Boom. Give me. I should have went one more character on those. But yeah, so this is going to generate all of the keys. And it's much faster when you don't run it with the console logs. So let's just I had these commented down. That's why. Let found equal, and then go like that. And then all we gotta do is hit refresh, and then let's grab all of this, but not that because that's not code. And let's just go like that. And this is still running. Let's close it. Let's kill it. Task manager. But yeah, so there you go. You guys should definitely follow back through that. Watch it maybe a third, fourth, fifth time. I know I will again because hell, I might even redo this video. I don't know. But yeah, the new terminal in Windows is a little strange, a little funny. Funny. I guess the new terminal works well enough since you've used it this whole time without any. Yeah, I have not had any problems. I did add this to the config. I haven't had any problems with the command prompt. There was one weird thing. What was it? Was it PowerShell? I think it's just PowerShell. Yeah. Since PowerShell is like apparently a universal app or something. Right? No, that's where it's at. I wanted to. It's not a problem, but I wanted to show just the name of the terminal, not the path that it's at, in the title. And I haven't yet worked out. I didn't spend much time on it, but I haven't worked out how to get it to do that yet. But yeah, it'd be nice if it didn't show a full current directory, or at least give you the option. But yeah, so let's just go to about blank. And is this on the right screen? Yes, it is. Console, paste. See if this works. Oh, it's running. So let's talk while this finishes here. It should give us an output of some number of milliseconds when it's complete. Does the little title command not work? Ooh, it would. I'm sure. Let's see. Title. Well, it wouldn't work here. Is there a bash equivalent of that? Set title. Well, that's now we have a fucking environment variable. Well, I'm sure it'll work in command. Title. Yeah. Ooh, I wonder if we do something stupid like this. cmd.exe. Is it -k title me? Hey, what do you know? Oh wait, now we're in command prompt though. Let's see here. -c. It doesn't work. Yeah, I don't know how to change the title in PowerShell. Never looked into it. I'm sure there's a way to do it here too. But yeah, it has not let down. Yet. I tried playing with the colors, and they seemed to not do anything. I tried changing them, and they really didn't change in the little config, which is here. Just going to take a while to load up. Of course, if you guys want to be able to access the virtual machine, just hit me up on Discord, and I'll make sure I get you credentials and how to get in there. There's a lot of tools for programming or reversing. You can use it. If I need it, I'll tell you, or I'll use something else. I don't have to use it, and it's there to be used when people need it. So by all means, do that. That's when somebody looking over your shoulder asks if you're right. You're running sudo apt update. Are you hacking the planet? Yeah, I guess. Do not recover. I don't care. The title command doesn't work in PowerShell because it's not a PowerShell command. There might be some stupid PowerShell command like this. Help title. Does this work? Get help. Searching help for title. Topic: Windows PowerShell help system. Description. Okay. Update help. What? No, I want title. That was so helpful. Get help title. that was beneficial. Now in here, if we just do something like that, it'll format it for us. We see like the different colors for the different GUIDs. I totally just made up a GUID for the default and set it to the dang Debian.exe. And then, yeah, I made sure that that was in my path. You can change between the schemes. They don't do a whole lot. This dark one looked the best, and then when I tried to go in here and change the colors to things that were more suited, it didn't do anything. What the? I will paste that. But that is interesting. Oh, yes. There you go. Change the title. You just got to go through that. um, that's a thing, I guess. That won't work here. Click. But yeah, so I tried changing these, and then it didn't seem to do anything. So it's still running. Is it still running? Found. Yep, definitely still running. Let's see. Now, as far as resources, is it using much? 16%. All right, let's see if we can speed this up. Hi. Apparently not. There must be some like limit set in the browser for how fast it can do JavaScript or something. I don't know. Wonder if Node would have done much better. I guess we could find out. Damn it. I hate it when I click in here because then you have a box and then your next click, that's copy. Then, yeah. Node. Oh, that's running. Let's see here. Details. It shouldn't take that long. I've done it before. Node is 13%, 14, 13. Doesn't care. Just to be fair, we'll set it to high too. Oh, can't. Love it. That's a lot of SVC host. The hell? I don't think I've ever seen that many. Like this. Select columns. Command line. Like this. Go. What are you? Net. Got some unnameders. Network. Dang. That is definitely a lot. Oh, hey, we finished. And where's my time? It didn't console log my time. Oh, damn it. Capital C. Son of a bitch. Console log. Anyways, so now you'll notice that these are not exactly unique. So we can't say that there's 3,715 of them, but we can get the unique ones. How do we do that again? It's like let f equal set. Oh, dang, I can't remember this. Do I have it anywhere written down? Probably not. I'm sure we can Google it. JS get array unique. That doesn't exist. No. Oh, there we go. Dot new set years. Yeah. So all we have to do is f equals dot 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 new set found f 1282 valid keys. Whoa, Mr. Raccoon. How do I read these? Is there text on that? Like, well, thank you, sir. Much obliged. Not. Oh, it didn't include a message. Okay, I've been confused because I don't know that anyone has. I think freaking Cat way back in the day when he first started watching, he was like the first person to ever send me a live chat, and I was like, "What is that? Did you?" Confused me. But thank you very much, sir. I often don't think that the information I put out is really worth any type of credit. I hope that at the end of the day, people do look at the videos and are able to learn something and find some type of value in the content. But quite frequently, I'll be thinking about it or I'll be watching it like, I need to redo these. A lot of these are either too in depth or too fast, or they don't go over some of the like assumptions that I made that some people might not realize. Being new, doesn't really matter since the chat is really slow. Oh, oh yeah, I guess you're right. Yeah, if I had a boatload of people watching, the chat was zooming by, and you wanted me to see something, then yeah, I guess that is kind of the business model of Top Chat, isn't it? You want your message read? Well, send them money. And don't they charge per character, or not per character, but like certain set number of characters? Anyways, this was a lot of fun actually, just writing something and then reading through the assembly to recreate what it did, and then think critically, how can we use that information to make keys? Is this the best way? No. Is it a way? Yeah. I actually wrote the same thing in Ruby, sort of as a proof of concept. Let me see if I have that here. Ruby. And it looked a little bit like this. Language R Ruby. So here you can see I took a non-nested approach where it's even uglier of the clock counting. If I had something I wanted to say, yeah, absolutely I would. Best way to use. Yes, I should port this over because I have yet to really play with it at all. So I agree. I will do that. Not right now because I'm getting ready to do some sleep. But I will definitely do that because this is kind of one of those fun things where you get to use a little bit of everything, and you can use a little bit of everything. You've got lookup, you've got conversions, you've got conditions and loops, and you do different ones. And eaches, like in Ruby, you can do each character, or you can do each byte, or you can do so like that same function in Ruby is right here, and let's do move to other window, first function. So here's our function, and here's that same function that I wrote in Ruby. Let me just kind of bump this down a little bit. There we go. And Pure Basic can solve all your problems. I've even seen it fix marriages. Oh, I love it. That's epic. Don't need these. And there we go. So the same function in Ruby, we have the alphabet, we have some array, we have some. What is POS? Oh, position? look up and yeah, see here I just declare it here F, and then once I self-modify F, I push it in, where I could just do, instead of F equals MC receives, that just means push, and then that's equivalent. Push that back down. And then XOR is on the same line. No, it's not. Why is this one plus equal? Oh, because this. Yeah. XOR same line, some variable, or F out, I called it here. And then see over here in Ruby, I did a while with the counter instead of a for, which here a for is even smaller. You know, here with the while loop, we have a counter, and then inside we have to increment the counter. This is 2 extra lines. Man, we didn't need to do. But in here, you see the math is the same. And then in Ruby, the last line is always the return, no matter what. So here we had to say return some value, and then yeah. So like we were saying in the last video where I was playing the game, was if you learn like the concepts and the principles behind how to think like a programmer, how to implement solutions, how to overcome hurdles, then you'll be able to do that in any language they throw at you, because programming is not so much about what language you do it in, it's understanding the concepts of how it's done. And then the matter of doing it can be done in any language. You may have to reference materials or look up syntaxes on how to implement that idea in that language, but it's all the same. And that's what I love about assembly, because if you can understand assembly, you can do anything. And that's why Radical Raccoon loves Pure Basic, because it's one of those that if you understand how to do it in that, it will help you way more than learning some like if you go learn C#, yes, the syntax is close, but a lot of the ideology or the principles behind how things work aren't really there to be understood. They don't need to be. Like there you have a string class. You don't have to know that, you know, a string is an array of characters, and if you want to compare a string, you need to, you know, figure out how to do that. Whereas in assembly days, before you had the ability to compare, you know, a start and a stop, there was an instruction for it. You do byte by byte, or word by word, or D word by D word. Yeah, so like that's my rant, I guess. Go learn Pure Basic. Only $49.90. I don't know how much, and it's definitely not a sponsor, but could be. I would shell Pure Basic. Go get yourself the demo version. Play around with that, and just do it. Now, what is the pricing? Oh, ordering. Pricing, ordering. One single user is €79. I don't know what that means, so it must be free to Americans. I'm guessing that's, I mean, is that euro? Does that mean euro? Like, I assume that means euro. But I'm kind of naive when it comes to international currencies. Like I've heard of euro, and I've heard of like Canadian dollars and Australian dollars, and I've heard of several of them, but correct me if I'm wrong, isn't there like a difference between a euro over here and a euro over there? Like, isn't there two that use a euro? I could be wrong. Where is Euro used. Oh yeah, so I doubt that they have the same value across all these places. That's confusing. And then like the Great Britain pound, like what? Yeah, okay. I'm going on a tangent now. I need to clearly go to sleep. Anyhow, this has been fun. We got to the end of this, not this, and you know what's bad about this? I don't know how to close this window. I can do this to do that. Oh, it's down here. I'm a genius. All right, figured it out. Anyways, if me making myself look stupid will make you remember how to do it proper, I'll do it all day. Oh my god, Cat 5, you're so late. Or you're very early. Hey, I was literally just kind of wrapping up and telling everybody I was tired and getting ready to go to sleep and how fun this was and how I'm glad that we were able to get this all done here. So we finished it and we ended here at the first video. And then this video, we had to figure this out. And it doesn't look like much, but it was definitely more. I know you just woke up, and I'll do you a favor. I'll end the stream so that when you get time, you can watch it. The first one was fun, too. Then 5 a.m. came. I know, right? I was, during the break, I was like, man, I'm kind of tired, but no, I got to do this video. Like, it needs to be done. We need to get it finished so that we can move on to something else, something more than sitting. And then I was like, all right, let's go. And then you can tell too, like in the first part of the video, I'm just like, all right. It took me like a half an hour to even get started. And then get started. And yes, I will regret it at about, in about 4 or 5 hours when 5 hours when I'm at work going, oh, I'm tired. Anyhow, tried that far too many. Yeah, I agree. Radical. And yeah, so then I woke up. We got this finished. Now we're talking. Now I'm rambling. I'm going to get going. You guys have fun. Read through this. Read through it again. Learn it. And never stop learning. You're never too old to learn. There's 2 more that I'm forgetting. Good night. Technically morning, yes, but see you guys next time.